Hi, fifth graders. It's me, Hadley, and I'm here to teach our very first Cabbage Chemistry Lab number 1, all about atoms and elements, and molecules and compounds. I just want to announce that this is my first video, and it could be a little cringy, but I'm excited to work with you guys. I really wish I could be in person with you, but please be gentle on me, because I don't think a lot of us teachers really like to be on video. But anyway, here is what you're gonna need for this project. You're gonna need your science journal if you brought it home. If you didn't bring it home, you need any old notebook or a few pieces of paper. I encourage everybody to have some kind of science journal that they can have to write down their observations. You're gonna need your iPad, obviously, to listen to this video and to follow along. If you want to use your iPad to draw pictures, because we're going to draw pictures, you can use your iPad for both watching this video and taking notes and drawing pictures if you want to do that. I can't teach you how to do that, but you can do that if you know how to do that. You're also going to need several markers of different colors, and you're going to need gumdrops of different colors, at least 4 different colors, and you're going to need toothpicks, because we're going to do some 3D models of molecules. And today I'm very excited to introduce, which I'm sure you've all heard of, the mighty atom. And what are atoms? They are the basic building block of all matter. My hair, my skin, my vest, gummy bears, the coronavirus, all of these bits of matter are made up of a very unique combination of bazillions of atoms. An element, which I get to present one of my very favorite charts, an element is one type of atom, and this is the periodic table of elements. It's one of my favorite charts in the whole world, but this is a very organized chart, and we're going to go over what it means, but I'm very excited to introduce this to you. So without further ado, what we are going to do in the next part of this video is I'm going to turn my iPad to a screen view, and I'm going to have you guys follow along with me while we draw some pictures of atoms. So get your paper and pencil ready, and we're going to have a lot of fun. All right, bye. Hello, this is Hadley, and here I have the periodic table of elements, my favorite little chart. And I'm just going to show you some things on this chart so you can start understanding how it's organized. So right here, I'm circling hydrogen. It's the first element on the periodic chart. It has this atomic number of 1, which indicates that it has 1 proton. Okay? These are all ordered in the number of protons they have. So here's helium. Helium is the gas that you put inside of a balloon to make it rise. And helium has 2 protons. Okay? So you can see the atomic number right there is 2. Here is oxygen, and oxygen has 8 protons. Okay? So it's ordered from 1, 2, 3, 4, 5, 6, 7, 8. Does that make sense? And now I'm going to circle copper. It has 29 protons. And I'll circle down here uranium, which has 92 protons. Uranium is one of those elements that we use in making nuclear weapons or nuclear power. Copper is we use to make a lot of our water pipes out of, and pennies, obviously. So this table has a lot of fun things to look at, and everything is ordered by the number of protons. So you can see here there's iron, chromium, maybe you've heard of potassium. There's all kinds of things. So I really encourage you to look at this chart. Okay. The next thing we're going to do is I want you to get a brand new clean piece of paper. I'm going to switch to a black pen. I'm going to make a key box right here. This is my key box, okay? And I want you to write hydrogen, okay? This is how you spell it. and I want you to do an H with a 1, okay? That 1 indicates how many protons it has. And then I'm going to get my blue pen, and I'm going to do a little P with a plus and a circle, and that is my little proton particle. So I have a P with a plus, which equals proton, okay? I love that protons start with P because they are positive. P positive proton. So this electron, this is not an electron. This proton has a positive charge. Okay, the next symbol I'm going to put in here is an N with a circle around it. And this equals a neutron. Okay, neutrons are a neutral little particle. They don't have any kind of charge. The next thing I'm going to do is I'm going to put a little yellow circle around my proton and neutron just to indicate that this is a nucleus. And I'm just going to write this out for you so you know that, like in cells and like in an egg, this nucleus, it's not wrapped by a membrane, but the protons and the neutrons are always bunched together. Okay. The next thing that we're going to do is I'm going to turn this into green, and I'm going to make an E with a minus sign, and I'm going to write electron. Okay. And electrons are busy little tiny particles that are much, much, much smaller than protons and neutrons, and they can be placed anywhere in this general space. So I know this doesn't look tinier because it's hard for me to make it much tinier, but there is an electron. And electrons kind of spin around the nucleus in an orbit of sorts. It's kind of like an orbit. We don't really know exactly what it looks like, but there's all these different levels of orbits. So this is how we imagine it to look. Okay, so that's the electron. Now, I want you to know that electrons, I'm just going to show you with this, they're very busy. They move around a lot, okay? The proton and the neutron stay the same, or stay right there. The other thing about electrons is they love to come and go. So they can go from one atom to another atom, and this hydrogen atom could be positively charged if this electron escapes. And if another electron decides to latch on, it could be negatively charged. So that's just a little bit of information to kind of help you start to think about the differences between electrons and protons. The other thing I want you to know, I'm just going to do this, is generally speaking, protons equal the number of electrons in an atom, although the electron is free to come and go, okay? Whereas protons and neutrons aren't always the same. Sometimes there are atoms that have more protons than neutrons. So it's kind of confusing, but generally speaking, protons equal electrons, okay? Okay, so now what I'd like you to do is make a brand new page. We're going to do a new element. This is my key box. And the element I've chosen is carbon. And I've chosen this because it is the element of all life. Okay? So gasoline and oil and our food and our bodies are all made of carbon. Wood is made of carbon. We could not live on this earth without carbon. There's chains of carbon that are ordered in all of these different shapes, different numbers of carbon, and it's pretty much the element of life. So carbon has 6 protons. So now what I'm going to do is I'm going to change to blue, and I'm going to do 6 protons. 1, 2, 3, 4, 5, 6 protons. Okay. And then what I'm going to do is I'm going to keep my blue. I'm going to do proton positive equals proton. Yay. And now I am going to do an N, and I'm going to do 6 N's. 1, 2, 3, 4, 5, 6. 6 N's, okay? And then I'm going to keep it right there. I'm going to do my N, my N equals neutron. Nice. I'm just going to circle this so you know that this is the nucleus, okay? This is the nucleus of my atom. And I'm going to make my electrons. And I am not 100% certain about this, but I think there's 3 orbits with carbon. So I'm going to do 3 orbits. And I'm going to put 1 electron on this first orbit. There's 1. I'm going to put 3 on this one. 1, 2, 3. And then I'm going to put 2 on this outer one. 1, 2. Okay? And like I said before, remember, these guys are constantly moving around this nucleus. I'm going to erase that. Oh, okay. And they constantly come and go. Okay? Electrons can come and go. So that is my carbon. We forgot to do this. I want you to do this just so you have it in your notes. We're going to do E equals electron, okay? And if you guys want to make more, you're welcome to make more of these. But that is basically what an atom is. Hi, 5th graders. We are here for the 3rd part of this first lab. Right now, we're going to make 3-dimensional molecules and compounds. So first, I want to describe the difference between molecules and compounds, because you're going to hear those words a lot. And it's a little more complicated than I'm going to describe, but I just want to give you the basics so you know what the definitions are. But a molecule is composed of 2 of the same elements. So for example, hydrogen, these are my little happy atoms. Hydrogen loves to be with another hydrogen all the time. It doesn't like to be apart. So whenever hydrogen is by itself, it's always going to attach to another hydrogen. And that's just because it likes to share their electrons with each other. So if you look at my little helium atom, helium is the next on the periodic table. Helium doesn't have any magnets to bond with. Helium likes to be all by itself, bouncing around in that balloon and rising up. But hydrogen loves to be apart. And when you try to break hydrogen apart, you create a ton of energy. And that's kind of the basis of hydrogen electric cars, is trying to get hydrogen to pull apart and create energy. So it's much more complicated than that, but that's kind of the basics. Anyway, nitrogen likes to bond with other nitrogens, so that's a molecule. And there are even molecules like C60. I don't even know what C60 is, but it's 60 carbons all bonded together, and that would be considered a molecule. Whereas a compound is a substance of 2 or more different elements. There can be molecular compounds that are bonded by a molecular bond. So it can be a little bit confusing, but if you see 2 or more substances or elements bonded together, that's a compound. So you're going to hear me say the words compound and molecule a lot, and I just wanted you to know the definition. Okay, so our very first one is water, H2O. So with my happy atoms, I have, there's 2 oxygen, you can see by that little subscript 2, and then there's 1 or did I say 2 hydrogens and 1 oxygen? So here's my oxygen in the middle, and here are my 2 hydrogens, and this is what a water molecule looks like. So in a glass of water, there will be billions upon billions of this molecule kind of floating around in that glass of water. So here's how you're going to make it with your model. You're going to take your oxygen, because there's 1 of them, and give it 2 legs. And then we're going to put our 2 hydrogen on, or these, wait, hydrogen, whoops. There is my water molecule. So in a glass of water, there's going to be billions and billions of those. Our next one is carbon dioxide. Carbon dioxide is the gas that's in our fizzy drinks. It's the gas that we breathe out. It's a gas that makes dry ice. It's a very abundant gas on planet Earth. So carbon dioxide with my happy atoms looks like this. We've got a carbon atoms or elements mixed with 2 oxygen elements. Okay, so you're going to take your carbon in the middle, and you're going to give it 2 oxygens, 2 bonded oxygens, like so. And there is your carbon dioxide. When you breathe out, you're probably breathing out billions of these molecules, I should say compounds, that are being pushed through the air with your breath. All right, the next one is table salt. Who would have ever thunk that table salt is a compound made from sodium and chlorine? So believe it or not, this compound chlorine is a poisonous gas when it's by itself, but when it mixes with sodium, which is this weird Na symbol, it makes sodium chloride, which is table salt. And it has a very special bonding structure. I'm not going to go into detail about it, but it likes to bond with a whole bunch of these in a square. And so that's why you see the crystal form of salt. When you look at a salt crystal, there's a few salt crystals on here. You probably can't see them, but within one of these tiny little salt crystals, can you see that one? Within that tiny little salt crystal, there's probably millions of these in that salt crystal. So, you're gonna make it with your gumdrops or your marshmallows, and you're gonna take 1 chlorine and 1 sodium, and there you have it. Table salt, sodium chloride. Okay, the next one is NH3, and NH3 is ammonia. And ammonia is a cleaning fluid that a lot of people use to clean their houses with. Some of you might have ammonia at your house. It's a little more toxic than Clorox bleach. So people tend to use bleach more, but I bet your grandparents probably used ammonia to clean things. But I thought, people are using a lot more ammonia these days with the COVID virus running around. So I thought ammonia would be a good one to make. So it's NH3. So you're going to take your white, and then you're going to give it 3 bonded legs of hydrogen. So we're going to take a hydrogen here, hydrogen, and there is NH3, hydrogen, ammonia. And now my favorite one of all, which hopefully will become your favorite, is the famous CH4. What is CH4, you ask? Well, it's 1 carbon and 4 hydrogens. But what is CH4? It is your farts. So, yep, believe it or not, your farts are called methane gas, and this is what it looks like. Let's see if you guys can make a CH4. You're going to pick 1 carbon, and you're going to put 4 legs in it. 4 legs in this carbon. And we're gonna put 4 hydrogens. Ooh, that's a funny gumdrop. Here we go. So there you have it. When you toot, there's going to be millions of these following you around. One of the biggest producers of methane gas in the world are cows, munching away on all of that grass. So there you have it, boys and girls. Those are some of the most basic compounds and molecules that we have on planet Earth. There's millions of compounds that can come together, millions, and some of them have long chains of many different elements. So I encourage you to look up on Google if you're wondering, well, can I mix 7 H's with 5 O's? Look it up. Write in Google, do H4O6 and see if it's something that you've ever heard of. And then maybe you can make it with gumdrops and toothpicks. But I hope you had a lot of fun, and I will see you in the next lab. Bye.